Hours before the ground begins to move, animals sometimes change their behavior. Subtle signals travel through earth and air, signals that certain species may detect long before humans can measure them.
For centuries, humans have reported unusual animal behavior prior to earthquakes. Ancient records from Greece, China, and Japan describe animals fleeing settlements, refusing food, or displaying agitation in the hours or days before seismic events. Domestic animals, such as the dog and cat, are frequently mentioned in modern accounts. Observers report barking, restlessness, or attempts to escape confined spaces shortly before tremors occur. Livestock, including cattle and horses, have also been observed moving collectively or showing signs of distress prior to seismic activity. In some documented cases, wildlife, such as birds or amphibians, vacated nesting or breeding areas unexpectedly. Despite the consistency of these reports across cultures and time periods, controlled scientific verification has proven difficult. Earthquakes are unpredictable, and behavioral changes in animals can have many causes. Nevertheless, the persistence of these observations suggests that animals may be responding to environmental signals not easily perceived by humans. One of the most widely studied explanations involves the detection of low-frequency vibrations. Before the main shock of an earthquake, smaller seismic disturbances, known as P waves, travel through the ground. These waves move faster than the more destructive S waves and surface waves that follow. P waves are often too subtle for humans to detect without instruments, but many animals possess highly sensitive mechanoreceptors. For example, the elephant is known to detect vibrations through its feet, using specialized sensory cells that respond to ground movement. Elephants can perceive seismic signals over long distances, a trait used in communication as well as environmental awareness. Similarly, burrowing animals, such as rodents, may detect changes in soil vibration more effectively than surface-dwelling species. This sensitivity could allow animals to respond to early seismic activity seconds or even minutes before humans become aware of it. While this does not constitute long-term prediction, it may provide a short window of advanced warning. Another hypothesis suggests that animals respond to chemical changes in the environment prior to earthquakes. As tectonic stress builds within Earth's crust, rocks may release gases such as radon or generate charged particles that alter local air and water chemistry. Aquatic species, including the toad, have been observed abandoning breeding sites prior to certain earthquakes. In one well-documented case in Italy in 2009, common toads left a pond days before a major seismic event and returned only after the activity subsided. Researchers proposed that changes in water chemistry, possibly linked to increased ion concentrations, may have triggered this behavior. Fish and amphibians are particularly sensitive to chemical fluctuations in their environment, as their skin and gills interact directly with surrounding water. While evidence remains limited, these observations suggest that chemical signals could contribute to pre-earthquake behavioral changes. Some scientists have explored the possibility that animals detect electromagnetic disturbances associated with tectonic stress. Laboratory experiments indicate that certain species, including birds and insects, can perceive weak electric or magnetic fields. The pigeon, for example, uses Earth's magnetic field for navigation. Similarly, some fish and sharks possess electroreceptive organs, capable of detecting faint electrical signals. As rocks fracture under stress, they may generate electromagnetic emissions. These signals are difficult to measure consistently, but they could influence animals with sensitive detection systems. Behavioral changes linked to these signals might include disorientation, altered movement patterns, or avoidance of specific areas. Although this hypothesis remains under investigation, it offers a potential mechanism for early detection that does not rely on mechanical vibration alone.
Despite numerous reports, the concept of animals predicting earthquakes remains controversial within the scientific community. One major challenge is the lack of consistent, repeatable data. Animal behavior is influenced by many factors, including weather, predators, and human activity. Distinguishing earthquake-related changes from normal variation is difficult. In addition, earthquakes themselves vary widely in location, depth, and magnitude. Signals that precede one event may not occur in another. Efforts to use animals as early warning systems have produced mixed results. In the 1970s, Chinese researchers attempted to monitor animal behavior for earthquake prediction, with some reported successes. However, subsequent attempts failed to produce reliable, consistent outcomes. Modern research increasingly relies on instrumental monitoring, including seismographs and satellite data, which provide measurable and reproducible results. Nevertheless, interest in animal behavior continues, particularly as new technologies allow more precise tracking of movement and physiological responses. While animals cannot currently be relied upon to predict earthquakes with precision, their sensitivity to environmental changes offers valuable insight into natural sensing systems. In recent years, researchers have begun using biologging technology, small devices attached to animals, to monitor movement patterns in real time. By analyzing large datasets across multiple species, scientists hope to identify consistent behavioral patterns associated with seismic activity. Early studies suggest that some animals may alter their behavior hours before earthquakes, particularly when exposed to combined environmental signals such as vibration, chemical change, and electromagnetic disturbance. These findings remain preliminary, but they highlight the possibility that animals integrate multiple sensory inputs in ways that differ from human perception. Rather than viewing animals as predictors, scientists increasingly see them as sensitive observers of environmental change. Their responses may not forecast earthquakes in a precise sense, but they provide clues about subtle processes occurring within Earth's crust. Understanding these responses could contribute to broader efforts in monitoring and interpreting natural hazards. Thank you for watching. Subscribe for more explorations into the hidden connections between animals and their environment, where behavior may reveal signals we are only beginning to understand.